All right, we're going to do some derivative examples here. And I'm not going to give away exactly what we're going to talk about. I'm going to show you. So, does this look like a fun problem to find the derivative of? Yeah, that's kind of crazy. So, if you look at this problem, there is a lot going on here in terms of derivatives. You have a quotient, you have a product, you have a chain rule, you have a power rule. There is a lot going on here, and trying to figure out the order in which to do the steps is very cumbersome, and it ends up being a very nested problem, one rule inside of another inside of another. So this question would actually be a nightmare in order for us to solve it as is written. So today, what I want to do is I want to show you how what we've been talking about, logarithms, can help you simplify a complicated problem as far as derivatives are concerned, like this one. So here's your trick. If I had a logarithm on here, on the right-hand side, we could break this up into separate, smaller terms. The problem is I don't have a logarithm. So what can we do? Well, could I just throw a logarithm on the right-hand side? Yes, but whatever you do to the right-hand side, you also have to do to the left-hand side. All right, now that means now we have ln of y equals ln of that giant mess. Now, we have created a new problem. This problem is no longer y equals a function. It's ln of y, a function of y equals a function of x, which means because of this term on the left, we are going to have to use implicit differentiation. So if you haven't learned how to do implicit differentiation, if you haven't watched those videos yet, go back and watch them. Wow, I can't write. Differentiation. Okay, anyway. So we put the ln on both sides. On the right-hand side, we're going to use our log rules to break it up. So we have a product, and we have a quotient. Let's use those rules first, and then we'll go from there. So remember what I said before, if you have ln of multiple things going on, products and quotients, anybody on top gets a positive logarithm. So we have two terms on top, they both get positive logarithms, minus the term from the bottom. Are you ready to take the derivative? Almost, not quite. What can we do? Let's take this power and apply the power rule, not the derivative, the logarithm power rule. The logarithm power rule says we bring the 1/2 down and put it in front. So this is algebra, this is not derivative. I have not started derivative anywhere. Everything I've done so far is just algebra. You do not start the derivative until every term is ready. So let's just bring everything down and make sure we're all good to go before we start taking the derivative, the implicit derivative. All right, I don't see anywhere else we can expand using log rules. So we have 4 terms, 1 on the left and 3 on the right, where we can apply the derivative rules each separately. So a much simpler problem because we took one big problem and broke it up. All right, so we're going to take the derivative of the left-hand side, and we're going to take the derivative of the right-hand side, each with respect to x. So remember, we're doing implicit derivative here. All right. Do you remember how to do an implicit derivative? You use your normal derivative rule. So what's the normal derivative rule for ln? 1 over your inside. The inside stays the same. But then you got to multiply by what? Finish the chain rule here. The derivative of y with respect to x. So that's the left-hand side. So a lot of students are going to forget this 1 over y. Don't forget, you have to take the derivative of the left-hand side. It's not just dy dx. On the right, everything's x's, so no more dy dx's to deal with. Just take the derivative. So ln, the rule says you do 1 over the inside times what? The derivative of the inside. Plus the 1/2, he's a constant multiple, he just chills out. Times the derivative of ln, well that's 1 over the inside stays the same, times the derivative of the inside. What's the derivative of x plus 3? Just a 1, so that's gone. Minus 1 over the inside times the derivative of the inside. Again, that's just 1. So let's keep working this out. Just clean it up. Our ultimate goal is to find dy dx. So Let's just get dy dx by itself by getting rid of the 1 over y. How would I get rid of 1 over y so that dy dx is by itself? Multiply by y, because it's in the denominator, to cancel it, and then do the same thing to the other side, the entire side. Okay? So dy dx is equal to, let's clean this up. So we have 2x over x squared plus 1 plus 1 over 2 times x plus 3 minus 1 over x minus 1. All of this multiplied by y. But what is y? Is y really y? Well, remember, our original problem had y by itself. So we know what y is. We can plug that back in. So take your original question and plug that in for your y value, and that's it. So let me see if I can remember all this. So x squared plus 1 times x plus 3 to the 1/2 all over x minus 1. Let me make sure I copied that right. Yes, there you go. Now, if you wanted, you could distribute it into the parentheses, but I would say that this is simplified enough to where my lab would be happy, and this would probably match the answer if this was a multiple choice question. We're not trying to test you on the algebra, we're trying to test you on the derivative, so this is probably how it would be presented to you. Let's try another one. So again, on the right-hand side, we have a fairly complicated function. It has 3 terms multiplying. All of them are in the denominator, so it's also a quotient rule with 2 product rules. So if we could apply ln to both sides, we would be able to expand the right-hand side into something that's hopefully easier to take a derivative of. So on the left, we have ln of y. On the right, let's expand it. So ln of what's on top, he's a positive ln. Everybody else is on the bottom, so they're all going to be negative ln. So negative ln of t, negative ln of t plus 1, and negative ln of t plus 2. It's expanded. Can't expand it anymore. There's no powers. There's no more product rules or quotient rules. So we're ready to take the derivative. Take the derivative with respect to your variable. In this case, that's a t. So d dt. So in this case, you're not going to have dy dt. You're going to have you're not going to have dy dx, you're going to have dy dt. Be careful to keep track of your variables. Okay, on the left, we have to take the derivative of ln. Why don't you pause the video and give this a try on your own and come back and see if you get it right. All right, here we go. Derivative of ln, 1 over the inside times the derivative of the inside with respect to t equals. On the right-hand side, well, let's talk about this guy right here. What is this? ln of 1. Well, he's actually equal to 0, so he's actually gone. We don't even need to worry about him. I could have simplified him earlier, but I've missed it. Minus the derivative of ln of t, that's 1 over t, times the derivative of t, which is just 1. Minus the next ln, 1 over the inside, times the derivative of the inside. What's the derivative of t plus 1? 1. Minus 1 over the inside times the derivative of the inside. Again, a 1. So this one's not too bad. All right, now we are actually trying to find dy dt. So what do we need to do with the 1 over y? If you recall, I showed you in the last one that we multiply by y to get rid of it. Whatever you do to one side, you also do to the other side. So we now have dy dt all by itself. We can clean up our right-hand side, so just negative 1 over t minus 1 over t plus 1 minus 1 over t plus 2. All of this times y, but remember, y is what they started out with, so we can just plug that in, the original problem in, where the y was. So t plus 1, and t plus 2. And that gives us a function involving just t. And there you go. All right. So that's 2 examples down for you. Let me find another one. All right, this one looks exciting. So there's actually a couple options in how we approach this. Number 1, there's a lot going on here. So ln would probably be useful. But first of all, we don't have any rules for this square root when it comes to ln. So what would we do with the square root? Rewrite it. So this is x plus 1 to the 10th power over 2x plus 1 to the 5th power, and all of it to the 1/2 power. Now here's your choice. You could distribute the 1/2 to each of these powers, or you can leave it on the whole thing. For discussion's sake, I'm going to leave it on the whole thing, and that'll actually show you basically both options. So we're going to take the derivative of both sides, d dx this time, our variable's in x. Oh, what am I doing? I'm not ready to take the derivative. First, I have way too much going on. I've got to use what? A logarithm. I almost forgot the most important step is to simplify this before we take the derivative. So ln of y equals, on the right, we have a lot going on here. Which log rule would we use first? We have powers, we have quotient. What goes first? Well, this 1/2 is on everybody, so he'd actually be taken care of first. So the 1/2 will go in front. After we deal with that 1/2, then we have a quotient rule. So we have 1/2 ln of the top minus ln of the bottom. Now I've written something incorrectly here on purpose to make sure we understand what needs to happen. That 1/2 came down in front. It was 1/2 times the ln. So who should the 1/2 be multiplied by in the expansion? It should be multiplied by everybody. So it's your choice. You can distribute it, or you can leave it on just in the front and put parentheses around everything else. It's really up to you. I'm going to distribute it though, because in the next step, these powers are going to come down and go in front. That way, I really have only one constant multiple in front of each term. I think it's a little bit easier, but technically you could leave the 1/2 in front of everything. So 10 times 1/2 is just 5. ln of x plus 1 minus, this one doesn't reduce, so 5 over 2, ln of 2x plus 1. All of that so far is just algebra. Now we still have to take the derivative. So d dx, I'm ready now because there's no more expansion available in terms of logarithm rules from algebra. So on the left-hand side, what's the derivative of ln? 1 over the inside times the derivative of the inside, dy dx, equals. The 5 chills out, he's a constant multiple, and we take the derivative of ln. So 1 over the inside, forgot my brackets up here, so I'm taking the derivative of everything there, times the derivative of the inside, which is just 1, minus the 5 over 2 is a constant multiple, he just chills out. The derivative of ln is 1 over the inside times the derivative of the inside. This one actually has a derivative. It's 2. We can simplify by reducing the 2's. And what do we need to do to find dy dx? Get rid of the y. How do we do that? We multiply to get rid of it. Whatever you do to the left, you also have to do to the right. So there's your dy dx. I'm going to clean it up just a little bit. So we have 5 over x plus 1 minus 5 over 2x plus 1 times y. Well, what's y? Remember, always bring the y back in if you know what it is. We started with y. So square root of x plus 1 to the 10th power over 2x plus 1 to the 5th power. And that's it. That's where you would stop. That's the derivative of the original function. All right, got it. All right, save the best for last. This one here is not just about simplifying and making the derivative easier. It's actually all about making it possible to take the derivative. We have a rule if you have x to a number, how to take the derivative. We have a rule if we have a to the x, where a is a number. So there has to be a number in one spot or the other. In this case, we have a function of x raised to a function of x. None of our rules actually tell us how to deal with that. So what are we going to do? We're going to separate the two functions from each other. How can I separate a power from its base? Well, we'd have to use a log rule. To use the log rule, you have to put ln on both sides. So if we have ln of y equals ln of sine of x to the x, how can the ln help us? ln has a power rule. What does the ln allow us to do with a power? Bring it down and put it in front. So we are going to be taking the derivative of this new equation here, which involves the original but written using log rules. So we have a product. We're going to have to deal with that on the right. And we have a function of y on the left, so we're going to have to use implicit to take the derivative. So let's do it. We're dealing with x, so d dx to both sides. And let's start with the lift. I think we've done this a couple times, so hopefully you've caught on. The derivative of ln is 1 over y times the derivative of y with respect to x equals product rule. All right, let's write down the product rule. So we have u prime v plus u v prime. I think I should write this on the side. U is x, then v is ln of sine of x. So I'm writing it on the side because v looks like it could be a little bit interesting. The derivative of u is what? 1. I want you to try the derivative of v and then come back. See if you can work that part out. All right, hopefully you tried. The derivative of ln of sine of x. What do we need here? Well, we have two functions, so we need the chain rule here. The outside function is the ln, the inside function is the sine. What's the derivative of ln? 1 over the inside, where the inside stays the same. But then you have to multiply by the derivative of the inside. What's the derivative of sine? Cosine. Okay, so this is cosine of x over sine of x. Which some of you might be saying that's an identity, and you're right. So if you want, you could write cotangent of x instead. All right, let's do our product rule then. So u prime times our v plus u times our v prime. We're almost done. We need to find dy dx, so we have to get rid of 1 over y. We multiply both sides by y to get rid of it on the left. Remember, we have it in our original question, so we can bring the y in to our answer. So ln of sine of x plus x cotangent of x, all of this times our original y, sine of x to the x. And there you go. So hopefully those derivatives where we used logarithms to simplify are good examples for you and help you get started on your practice. Make sure you practice. These are very important for practicing. And I'll see you in the next video.